So this video is going to demonstrate how to make a simple brick breaking game. So let's get right into it. You see we have an empty scene and we have three assets that have been imported from an external folder. So let's start by making the border. Let's take this image. It's simply a white block. What we're going to do is we're going to scale it, and that way we can use it for the various borders. So let's take the X scale. We'll make it a little more narrow. Let's make it 0.5. And we'll make the Y, let's make it 11. Looks 10's almost right. So let's slide that over. And you can see this rectangle is the camera. So we'll slide that so we can see some of it. Now let's change the name of that to left border. Left border needs add component, physics 2D, and it needs a box collider. So now, as the name would suggest, it can detect collisions. We're now going to take that, we're going to right click, we're going to copy, we're going to paste, we're going to rename this right border, slide that over, and as you can see it has the same components of the left border because we added the components first and then copied it. Let's take one more. So we're going to copy this and paste it one more, and we'll call this top. We'll keep the naming convention the same and call it top border. What we do with this is we're going to rotate this on the z-axis, and now we can just move this around with the arrows, and looks good. Let's quickly run it to see how our borders look. Alright, so the right is a little bit too far over. That's good enough. The top is a little bit too wide, but this is just meant to be the broad strokes anyways. Okay, so there's our border. They all have box colliders, so collisions will be detected. Let's now take that same image and let's call this paddle. So this is what you're going to be able to control. So we're going to shrink the vertical, and we're going to scale the horizontal. And this is going to be one of the aspects of game balance. Exactly how big should this be? How wide should it be? Or maybe there's going to be power-ups that change the width. Another attribute that is going to be a game balance decision is going to be the speed in which it moves at. So let's start by adding the physics 2D box collider just like we did the borders, so as that it can detect a collision, but it also needs physics 2D rigid body 2D. And now we can add velocity because you're going to need to move it. For constraints, put a check for it says freeze rotation Z. Remember how I rotated this just a couple minutes ago? Well, if something struck this, the same thing would happen. This thing would spin along the z-axis. You don't want it. You want it to be frozen on the z-axis. So our paddle has a box collider and has a rigid body. Let's make gravity scale 0 because we don't want it dropping. Okay, so that's the basics. Let's create some bricks to be destroyed. Now, there's a better method for making a screen full of bricks, but again, this is just the broad strokes, so I'm just going to manually create a few. So I'm going to drag and drop the brick image. Now, that brick might be a little bit small for your liking, so if you click on the asset itself, another way of scaling an object is by changing the asset itself. So rather than changing the object, you can change the underlying asset. See how it says pixels per unit? Because this is a ratio, if you make it smaller, If you make the ratio smaller, then the object gets bigger. So drop that down to 90. Get rid of mip-maps if there's a check there. Drop this down to 256 because this is not bigger than 256. And then click on Apply, and you can see it just grew a little bit. Again, broad strokes, so we don't have to get this looking perfect. It's just the basics. Let's go ahead and add a component to the brick. We're going to add Physics 2D, and we're going to add a box collider. We are not adding a rigid body because we do not want gravity to affect these. We're not going to add any velocity. Now, you can now, just like we did with the borders, you can copy the brick. And as I mentioned, there's a much better way to create a screen full of bricks. But we'll get to that either later in this video, or I'll just redirect to another video where I talk about something that's known as instantiation. Here we go, got a bunch of bricks to be destroyed. And if you want to be really fancy about it, you can then grab these, copy, paste, and you can create a second row. Now, as you can see, if you're manually creating all these bricks, very quickly this is going to get cluttered because you probably actually have like 5 times the amount of bricks that we have here. So it really gets a little unwieldy. So like I said, there's a much better process for creating the bricks. Again, this is just for demonstrative purposes. So we have our paddle, we have our border, we have a brick. Now we just need to create the ball. So we'll drag and drop that into the screen. Just move that so it's easier to see. We'll click Add Component, Physics 2D, Circle Collider. The border is a little bit too big, so you can click on Edit Collider, grab one of the dots and shrink it if you want. I'm not too worried about it. You don't want it to be too unforgiving, but you also don't want it to be too easy. So that's another aspect of game balance. So now it can detect collisions. We do not want it to be a trigger, just like the other objects. None of the objects are triggers, they're all solid. Add component, Physics 2D, Rigid Body 2D, no gravity. So now we can add velocity to the ball. So far, so good. We have our border, we have the bricks, we have the ball, and we have the paddle. Now, the ball is going to start off on the screen, but if a ball is lost, a new ball has to be created. We'll cover how to do that later. Again, that's also using something that's known as instantiation. For now, we just want to get the physics of the environment, and unfortunately, it's not quite as automatic as you'd hoped. We're going to have to put in a few commands, pretty straightforward math, that make sure the ball keeps moving, because certain objects, despite given a material, seem to absorb momentum, and so we just want to make sure that we keep everything moving. And it's actually good because you may have an environment where you specifically want to defy how you would think default physics works, so it's good to know how to tinker with it to begin with. Alright, so I've already written the scripts ahead of time in a text file. I'm going to copy and paste it a little bit at a time. I just don't want to waste your time watching me type. And then you can just pause the video. So, let's create paddle control. So click on the paddle, drag and drop the paddle control script. And now you want to open that. So basically all we want to do with the paddle is move it left and right. So to do that, first thing we're going to do is we're going to add a couple of variables. In Unity, there are lots and lots of types of variables. There's strings, there's ints, But there's also these key code variables. These variables are used to detect input from the player. So this script is attached to the paddle. So let's save this. So public key code move L, public key code move R. The actual name of the variable doesn't matter. That's just to indicate to you, the designer, what you're going to use this variable for. So we've added key codes for those two variables. Now watch what happens when we look at the paddle. You now have them here, and you can now designate letters. So we're going to use WASD control, so A will be left, D will be right. So A is move L, D is move R. That in and of itself does nothing. That just checks. It's not telling Unity what to do when you actually press those. So that's next. So in the update section, and if you want, you can delete these two remark statements. This just tells you that start is done in the initialization and that this occurs every single frame. It's a good reminder, but it doesn't actually have to be there. So in the update section, if parenthesis input.getKey parenthesis move L parenthesis. What this says is if that key is being pressed, then do something. Now there's various iterations of get key. There's get key down, get key up. Get key means that every single frame that the key is held down, this is true. So that's a rapid fire scenario. Whereas get key down is just the single first frame that the key is detected as down. So for every frame that the key is down, get component rigid body. So if you go back to the paddle, you see over here the various components. So paddle, as you can see, they're called components. And what are we doing? We're changing the rigid body 2D component. So get component rigid body 2D velocity new vector 2. So that means it's just x and y. We want a -5 velocity when you're pressing L because we want to move to the left of the screen, and we don't want to change the vertical. We're not moving up and down. This is also going to be game balance, how fast you want to move. Likewise, there may be buffs and debuffs that change the speed. Next, if input.getKeyMove R, so now we're checking if the D key is being pressed, get component velocity, so get component rigid 2D, rigid body 2D, velocity, new vector 2, and now it's +5. So in other words, if you're pressing the left key, go -5. If you're pressing the right key, go +5. One more. What this one is going to do, see right now, if you press the key, it applies the velocity. If you let go of the key, it doesn't remove the velocity. So this is going to look weird, so let's break it down. So the other ones say input.getKey move R or move L. This one actually has an exclamation point just before the input, because what this is actually saying is if this is true. The exclamation point in Unity is used to indicate the opposite, if something is not true. So this is saying if the move L key is not being pressed, and yes, it's a double ampersand, and the move R key is not pressed. So both, if this and this is not pressed. So you're probably going to want to pause the video to type this out, but it's open parenthesis, exclamation point, input, get key, open parenthesis, move L, close, double ampersand, open, exclamation point, input, dot key, open, move R, close. So why is it looking so crazy like that? the entire if statement, everything that's being checked, the entire thing has to be inside of parentheses. So that's these outer ones. Each individual value you're checking has to be in its own parentheses. That's that set and that set. And just to make it complicated, input uses its own set of parentheses. So you can definitely see things more complicated than this, but considering you're checking only two values, this one's fairly complicated. So again, if this and this are not true, then go ahead and get rid of the velocity. So sorry that was pretty long-winded, but if you get a handle on these if statements, they're very, very powerful. And that's actually it for the paddle control, so it's pretty straightforward. Move it left, move it right. If you're not pressing anything, then don't move at all. So this should work now. Let's run it. So left, collides with the wall, stops. Good.